Hello everyone, I'm Shilosripal. I'm a Prime Minister's Research Fellow, and today we are discussing this question from GATE Examination 2023 from the paper Life Sciences, question number 82. The question states, which of the following statements about the primary and secondary adaptive immune responses to an antigen is or are correct? Option A, IgM antibodies appear first in response to the initial exposure of the antigen. Option B, majority of the antibodies produced in response to the second exposure of the same antigen are IgM isotype. Option C, second exposure of the same antigen stimulates production of memory cells. And option D, primary antibody response has shorter lag phase than secondary antibody response. I should remind you that this is a MSQ type of question, so multiple options can be correct. So before solving this, let us look at the primary and secondary adaptive immune responses. At what point of the infection these responses are generated, and what is the difference between these two? So when there is an acute infection, what happens during an acute infection? So this graph here shows the course of an acute infection and how the responses, the innate immune response and the adaptive immune response, how these responses are generated from the point of entry of the microorganism. Now, when the microorganism enters our body, the foreign pathogen or the microorganism enters our body, starting from that point, it takes some time for the microorganism to establish the infections. This is the part when the this part is when the infection is established, and starting from when the microorganism enters our body, the innate immune response is generated. So right from the time when the microorganism is entering our body, the innate immune response is generated, and the innate immune response tries to restrain the pathogen in this period of time when the infection is being established. But if the innate immune response at this point of time cannot totally restrain the growth of the microorganism, and the microorganism continues growing, so you can see that the microorganism continues growing, then the adaptive immune response is induced. So this part number two, this is the inductive phase. So we can see that the adaptive immune response starts to um, initiate at this point of time, and the adaptive immune response is also it also begins. Along with that, the memory, the adaptive immune memory also starts to be induced at this point of time. So this is the inductive phase. But we can see that the level of microorganism is still growing, and the adaptive immune response is also beginning to generate. Following that inductive phase comes the effective phase. So now this level of microorganism. First of all, let me tell you one thing, that there is a certain level of antigen which is required to activate the activate the adaptive immune response, and that is called the threshold level. So once the level of microorganism reaches that threshold level, then from that point of time, the adaptive immune response is generated. So at this point of time, when the threshold level is crossed, then from starting from that point of time, the adaptive immune response is generated or activated. So this is the activation phase of the adaptive immune response, when the level of microorganism is still growing, but the adaptive immune response is also getting activated. And when it is fully activated, from that point of time, it starts to function. And when it starts to function, that is the effector phase. So obviously, because of that, the level of microorganism now goes down till it becomes zero, and that means the pathogen has been cleared. So this is the effector phase of the adaptive immune response. Followed by that, when the pathogen is cleared, the adaptive immune response does not stop at that period of time. So the adaptive immune response continues beyond the point of time when the pathogen is cleared. How that continues? That continues by the formation of the immunological memory. The memory phase is the formation and the um, maturation of the memory cells, the memory B cells and the memory T cells, which are responsible for providing protection against any subsequent entry of that same pathogen. So that is provided by the memory phase. So this is the typical course of an infection. The innate immune response is initially generated. If it cannot clear the particular infection, then the adaptive immune response is activated and which clears the pathogen. And after beyond that also, the adaptive immune response stays active because it forms the immunological memory. Now, what happens during this adaptive immune response? So we will discuss this adaptive immune response in more details. So if we inject antigen A in a body, in an organism, and that organism will immediately not uh, activate its adaptive immune response. So as we have seen here also, there is a certain threshold level of antigen which is required to activate the adaptive immune response or induce that adaptive immune response. So initially there is a lag phase. So this is the lag phase. This is the lag phase, which is a which lasts for a few days, and so this is the entry point of the antigen A. This is the entry point of the antigen A. Following the entry of the antigen A in the body, there is a little lag period when the adaptive immune response is not induced or activated. But following that lag period, the adaptive immune response starts to be induced and then it reaches a plateau. So this is when the effector phase is undergoing, and the when the adaptive immune response is fully activated, then it starts to clear up the pathogen. So the pathogen level goes down, and also the antibody level. So this here in the y-axis we can see the antibody level, and here in the x-axis there are number of days. So we can see like approximately after 4 or 5 days, the adaptive immune response begins, and approximately when it reaches like 12 to 15 days, 13, 14 days, then it reaches a plateau. So which means that the adaptive immune response is fully active at that point of time. So the antibody level, so the concentration of the antibody, it remains maximum, and then followed by that, when the pathogen is cleared, then the antibody level drops. So this is called the primary response. So what is primary response? Primary response is when the antigen is entering the body for the first time. So the immune system of the body is encountering the antigen for the very first time. And the response of the adaptive immune system in this particular time, when it is encountering the antigen for the first time, that is called the primary response. That is called the primary response. Now, if there is a subsequent exposure of the same antigen, then what happens? Then the secondary response is mounted. So now, if we inject both antigen A and B, then what will happen? So there is a gap here, so it is after a certain number of days. If we inject antigen A and B together, then the secondary response is generated. So what is the difference between this primary and secondary response? As we can see that this lag period is missing in the secondary antibody response. So the lag period of the secondary response is very, very short. So here, almost negligible lag phase, and also the antibody response is much more effective. How? Because the level of antibody, the amount of antibody that are produced is much, much larger in case of the secondary response. Why does it happen? This happens because of the immunological memory. As I mentioned that even if the pathogen is cleared, the uh, the memory cells remain in the body. So these memory cells can, when there is a subsequent exposure with the same antigen, the immune system recognizes that yes, it is the same antigen. So now those memory cells which were generated in the first response or the primary response, they will now be activated very quickly. So that is why there is a negligible lag phase. So they are now activated very quickly. As you can see, a rapid increase in the antibody level, and a large number of antibodies are also produced to deal with the antigen very quickly. So that is because of the immunological memory. So that happens in the secondary response when there is a second exposure with the same antigen. So now in this after this point of time, we can see that the antigen A, the body is showing a second exposure. The body there is a second exposure of the antigen A in this body, but the antigen B is introduced for the first time. So therefore, antigen B, the graph of antigen B here shows a very similar curve as that of the primary response. So that is why it has a much longer lag period. So this part is the lag period where the response towards antigen B is not activated yet, right? So this is the lag period of the antigen B response, and then the B response starts to increase, but slowly, not as rapidly as the secondary response. So these are the main differences between the primary and secondary response, that there is a shorter lag period in the secondary response, a very short lag period or a very negligible lag period, and the amount of antibodies, the concentration of the antibodies is also much, much higher in case of the secondary response, and the response is much quicker than the primary response. Hmm. Now, what are the antibodies that are produced during the primary and the secondary response? Now, as we can see here, that this is showing the time after immunization. So this is when the primary th that is the um, actually that is when the first uh, the antigen was introduced for the first time. So this is the immunization, showing immunization. So immunization means when uh, the when we are introducing a dead pathogen or an inactivated pathogen in the body, so that the body can generate its own memory cells, right? So this is the primary exposure of the pathogen. So this is actually the same. This is when the pathogen is first time introduced in the body. Now, this is the primary exposure. After this four here, that means after 4 weeks, this is actually on the x-axis. There is it is weeks. So here I can also write it down here. This is 1, sorry, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. These are the weeks. This is where the first immunization was done, the primary shot, followed by the booster shot, which is the secondary immunization, and followed by the tertiary immunization after 6 weeks. Okay. Now, what do we see here? So that means after the primary immunization, what are the changes in the antibody level? So we can see that um, since this is the primary response, so there is a longer lag period. After that, the antibody level starts to rise, right? And the antibody level reaches, like, for example, till we can say 50 mg per ml or something like that. And then when the pathogen is cleared, this response goes down. But these antibodies, they remain in the blood, but at a much lesser concentration. Now, this antibody is IgM. So, the first antibody that encounters the pathogen or that helps in clearing the pathogen is the IgM. IgM is the first antibody that is generated or that is produced to clear off the pathogen in the primary response. So, IgM is the first responder or the first antibody to clear off the pathogen to um, generate uh, the adaptive immune response in the primary response. Next, then what happens after IgM is produced? After a few days, IgG also start to produce. But the IgG level is lower than the IgM level in the primary response. So till from week 0 to week 4, the primary response is continuing. After week 4, we give a second booster of the antigen. So now what will happen that this IgM level has been gone down at that point of time. But after this secondary immunization or the second booster, the IgG level now goes up. Sorry, the IgG level now goes up very rapidly. So now we can see a rapid increase in the IgG level. So this is something what we call the secondary response, right? So now in the secondary response, we can see that the IgM level is still down, but the IgG level goes up. So the IgG level increases. So therefore, which means that IgM is the antibody that is produced during primary response, whereas during secondary response, the IgG is produced. IgG is much more effective than IgM, and which is why IgG is produced in larger number at the secondary response, which is followed by the tertiary response, um, actually which begins after the 6th week, because there is a next booster. There is a third booster of this antigen, and followed by that, the IgG level increases more, right? So the IgG level keeps on increasing after the consequent boosters. So which is why when we take a vaccine, we take booster shots, right? We don't take just one shot of the vaccine. We usually take shots so that the antibody level in our body can increase and it can be at a level where it can easily clear off the antigen if we get infected with that antigen naturally, right? So this is the antibody that is produced during the secondary and tertiary responses. And this is the antibody level. So here, this antibody level is in logarithmic scale. So please remember it, the antibody level increases in the logarithmic scale. So it's a huge, huge increase in the antibody level, right? Okay. And in the meanwhile, when the antibody concentration is increasing in the blood, the antibody affinity also increases. So this is a process which is called affinity maturation. This usually occurs for IgG, IgA, and IgE, but not for IgM. So we can see that the IgM affinity, which is approximately 10 to the power 5, it remains constant throughout the immunization. But the IgG affinity keeps on increasing after the secondary and the tertiary boosters, right? So the IgG level was also increasing, the antibody level was also increasing, its concentration in the blood was also increasing after the secondary and tertiary immunization. Also, its affinity was also increasing. This is a process. This is done by the affinity maturation, or which is also known as the somatic hypermutation, which increases the affinity of the antibodies. So that is how the body tackles any infection very effectively if there are memory cells against that particular pathogen by producing larger quantities of antibody and also by producing higher affinity antibodies, right? So now if we go back to the question and let's look at the options. The first one was, first of all, we have to identify the statements which are correct about primary and secondary adaptive immune responses. The first one was IgM antibodies appear first in response to the initial exposure of the antigen. That is correct. We have discussed this, that the IgM are the first antibodies to respond when there is an initial exposure with the antigen. Next option, majority of the antibodies produced in response to the second exposure of the same antigen are IgM isotype. That is wrong because the antibodies that are produced in response to the second exposure are majorly IgG antibodies, right? So therefore, this is not correct. Next, coming to the next option, second exposure of the same antigen stimulates production of memory cells. Okay, second exposure of the same antigen stimulates production of memory cells. That is also correct because we know that the memory cells are responsible for the secondary response of the antibodies. And the last option, primary antibody response has shorter lag phase than secondary antibody response. Okay, please read it carefully. Primary antibody response has shorter lag phase than secondary antibody response. But we know this is just the reverse, that secondary antibody response has shorter lag phase than the primary antibody response, right? So the lag phase is shorter for the secondary antibody response. So therefore, option D is also not correct. So therefore, the correct options here are A and C, right? So that's all. That is our answer. Thank you.